In STEM, we have science, technology, and engineering. But what about math? I'm going to teach you Euler's method, not Euler's. Let's go old school and write on paper. We have our differential equations of predator and prey. Our predators are coyotes and our prey are mice. And these differential equations are of time. So we have C prime of t and M prime of t. Our initial populations are 10 coyotes and 500 mice. So using 1-year intervals, what will the coyote and mice populations be after 1 year? So our 1-year intervals, that's time, and this is out of decades, so we have 0.1 as our change in time to be able to solve for after 1 year. So our change in time will be 0.1 to be able to get the 1 year we want of these populations. Then we have our frame to keep everything in order. We have step times C, comma M, C prime, comma M prime, our change in time times the C prime, comma M prime, and we have our old plus our new, which is everything we've done. So then our first step, we have time is 0 because in our initial populations, that's 0 years that have passed. So that's 10, comma 500. Then we plug this into our differential equations. The first is C prime. Our 10 will be the C and our 500 will be the M. We solve and we get C prime equals 498. Then we go into our second equation, which is M prime, and we get negative 150 after plugging in these values. Then we can write this in our frame, and we will move on to the next step, which is multiplying by the change in time. So it's 0.1 times the 498, comma the negative 150, and we get 49.8, comma negative 15. Then we have to add the old plus the new, and that's 10 plus 49.8, which is 59.8, and the 50 minus 15, which is 485. So then we can see that this is the end value for our first step, and that will be the start to our next step. So at time 0.1, our population is 59.8, comma 485. So after 1 year, we have 59.8 coyotes and 485 mice, as solved by these differential equations to be able to approximate the populations. So what we can see is that to approximate, we use linear approximation using tangent lines over a short distance. So math is more than just numbers. In STEM, we need math for all these components that make up STEM.